All right, so we're going to look at 5.8 today, which is about writing quadratic equations. And we know how to do this with a linear problem, right? We can write a slope-intercept problem with a slope and an intercept. I can write a point-slope form equation if I have the point and I have the y-intercept, or not the y-intercept, and a slope. So we can do the same thing here for a quadratic, and we can plug it into standard form. But instead of needing 2 points, like how we did for a linear, I'm actually going to need 3 points. So if I only have 2 points, I'm never going to be able to write this quadratic formula here. I'm only going to be able to write something that's potentially linear. So you're at minimum needing 3 points because we're going to set up a system of 3 equations, which this is a callback to our 3 variable unit there, okay? So the first thing that we want to do is we want to identify my x's and my y's, right? I have a list of x's, 0, -2, 1. I have a list of y's, 4, 6, and 9. And if we see something special, like what I'm given here, if I'm given a y-intercept, that is very, very helpful. Because we know by definition from standard form that my y-intercept is my c value, right? Because my goal is to figure out what is a, b, and c of standard form, okay? So I'm finding 3 variables. Well, if I know that this is my y-intercept right here, and how do I know it's my y-intercept? Well, x is 0, right? When x is 0, I'm not moving left or right, I'm only on the y-axis. So what I can say is that c equals 4. But if we want the mathematical proof for that, let's plug in this ordered pair. Every time I see y, I'm going to substitute in the value of 4. Every time I see x, I'm going to substitute in the value of 0. So I get a times x is 0 squared plus b times 0 plus c. Well, a times 0 squared goes away, b times 0 goes away. So again, I'm left with c equals 4. So no matter how you think about it, if you go the old-fashioned way of we can plug in, right, this formula here, this standard form, is just a placeholder for your ordered pairs. I just need to figure out what A, B, and C is. Well, now I figured out what C is, so that's great. And so now I can plug in my other ordered pairs. I have a combination of -2 and 6. So again, every time I see y, I'm going to replace that with 6. So I'll set up this next one. 6 equals, I'll make this one pink so we can tell the difference there. This first one was navy. Okay, I'll do the last one in orange. So -2, 6. So I get 6 equals a times the x value from the ordered pair is -2 plus b times -2 plus 4. Because I know c is now 4. So I'm down to only having 2 variables that I don't know. I don't know a, I don't know b. We can clean this up a little bit if we wanted to. -2 squared is 4, so that'd be 4a. -2 times b, we write that as -2b plus 4. I could then subtract that 4 over. So that way I have something in linear standard form now. 2 equals 4a minus 2b. And so this is a good place to stop here. I have unknown a value and unknown b value. But thankfully I have one more ordered pair that I can try. 1, 9. So every time I see y, I'm going to replace that with 9. I get a times my x is now 1 squared plus b times 1 plus 4. So if I clean this up, we get 9 equals 1 squared is 1. 1 times a is a. 1 times b is b plus 4. We can subtract 4. So my new problem here from my ordered pair 1, 9 becomes 5 equals a plus b. And what I have now is I have c found. Again, that's what I'm looking for. I have 2 equations with 2 unknown variables. This is able to be solved. So this is now a system, right? At this point, you can choose any method that you want to solve the system. Substitution, elimination, technically graphing, but I don't know why we'd want to waste our time with that. And I like to do elimination, so I'm going to do that. So I'm going to rewrite my problems. If I eliminate, I know I'm going to need to multiply this bottom one by something. I can either cancel out my A's or I can cancel out my B's. I'll just start with canceling out my A's. So I'm going to multiply everything by 4. So I'm going to write that right here, and I'm going to show, okay, I'm going to multiply by 4 here first to get my A's to cancel. And so when I do that, I get 20 equals, or sorry, I want to multiply that by a negative 4, right? So I have a negative 4a, and then minus 4b. And so now I have 2 minus 20, which is negative 18. 4 minus 4 cancels. Negative 4 minus 4 is negative 6. So therefore, when I divide by negative 6, I get b equals 3. So I now have my second answer. I know C is 4, I know B is 3. Now I can go through and I can do my last step of plugging all that back in to either formula here to find A. All right, so I'm going to go to the easy one, right? This one has A that doesn't have a coefficient in front of it, so that's going to be really easy to solve for. So I'm going to use this, and we're going to say 5 equals A plus B, but B is now 3. So when I subtract 3, I now find that A is equal to 2. And so we're used to being like, okay, cool, I found my answer. But we want to understand what the context of this is. Again, A, B, and C, I just found the coefficients of the standard form equation for a quadratic here. So this now becomes y equals, my A value is 2, x squared, plus B is 3, x comes after that, plus C is 4. So here is my formula for these ordered pairs. Okay, so I went from having a list of ordered pairs. Using that, I plugged in, notice how I plugged in every single ordered pair. I did that 3 times. I don't know why that undid that. Okay, so again, I did that 3 times. I plugged in 0, 4. I plugged in negative 2, 6. I plugged in 1, 9. Okay, I did 3 problems there to create 3 equations. One of them was nice and solve for C. The other 2 were not so nice. I did have both A and B, so then I noticed I had 2 variables, 2 equations left. I can do elimination or substitution there, and so that allows me to solve for the coefficients. Okay? Again, I'm allowed to do this because X and Y are just placeholders for your ordered pairs, right? You plug in some number, that is your problem there. This allows me to find A, B, and C. So let's try that one more time. But now, what if I give you a table instead? I said, here's a table of values. Go ahead and find that equation, write an equation for this quadratic. And just like before, if I give you a table and that table includes your y-intercept, I would start there, right? My y-intercept is 0, negative 3. My y-intercept is when x is not moving left or right, so that's why we're at 0. So I definitely pick this one. I like to go easy, so I'm going to pick the ones with the lower numbers, right? Negative 1, 2, 1, negative 2. Pretty easy. Okay, so now we can plug all 3 of these in. I'm going to start with the y-intercept one, though, again. So I'll go back to making this one. Again, x, y, this is an ordered pair. So we get y equals, sorry, not y equals. I'm going to actually plug in the value of y. Y is negative 3. So negative 3 equals A times x is 0 squared plus B times x is 0 plus C. Well, this just goes to show again that plugging in 0 here, both of the A terms and the B terms are going to go away because we're multiplying by 0. And I know that C is now negative 3. Again, that is my y-intercept. Then I can do that again. I can plug in this ordered pair now. Again, and you could choose any of them. You could choose this one or this one or this one. Do whatever you want. I'm just using the smaller numbers. So I can try to do this math in my head. So I get 2, that's my y value, equals A times x is negative 1, plus B times x is negative 1 again, plus negative 3, or let's just jump right into minus 3, right? If I'm adding a negative, that's just minus 3. And let's clean this up. So we have 2 equals negative 1 squared is 1. 1 times A is A. Then I have a minus B here, minus 3. By moving that 3 to the other side by adding it, I get 5 equals A minus B. Okay, then I can do the next one. So for this one, I can plug in 1 and negative 2. So this one becomes negative 2 equals A times 1 squared plus B times 1 minus 3. So we get negative 2 equals 1 squared is 1, so that's A. 1 times B is B, minus 3. Adding 3 over here, I get 1 equals A plus B. And because I chose such nice numbers, I chose the 1s and the 2s, I have a lot of coefficients of 1 here. And all I would really need to do is stack these 2 up on top of each other, and I can just eliminate down. Because notice what happens here. I have a b and I have a minus b. I can just add these together. My b's are going to eliminate. So I get 1 plus 5 is 6. A plus a is 2a. I can divide by 2 to find that a is 3. So I have c, I have a. I need to go back and plug that into either equation here to find b. So again, I'm going to go for the easy one, the one that has b as positive and no number in front of it. So we get 1 equals a, we just found to be 3, plus b. So when I subtract 3, I get negative 2 equals b. And so putting all this together, again, these are the coefficients that I've just found, not answers. These are not ordered pairs. I was given the ordered pairs, right? I kind of went in reverse. I used that format to find the a, the b, and the c. So my final answer would be y equals 3x squared minus 2x minus 3. A, B, C. Okay. You might be wondering, what if I do not have a y-intercept? Then what do I do? So there is one on the homework like that. So you might want to pause this video, get out your homework, and do that. And while we are moving towards the homework, here, let me clear this. I do want to give a little bonus opportunity here. If you're still listening, that, I don't know, what should the question be? What is your favorite ice cream flavor? I don't know. It's cold, but what is your favorite ice cream flavor? Put that in the private comments for a bonus point. Okay, so what if we look at number 2 here? You'll notice that number 2, I do not have a y-intercept. I don't have a 0, unfortunately. So what this one is going to do is going to make us go the old-fashioned way, the longer way. So I still want to plug in all 3 of my ordered pairs here. So let's do the first one. I get 5 equals, and then I have and if we need to write down the standard form, we can. Ax squared plus bx plus c. If we need to write that, we can. So we get 5 equals a times my x value is 3 squared plus b times 3 plus c. So I get 5 equals 3 squared is 9, so 9a, 3 times b is 3b, plus c. So nothing canceled out there. So I'm going to keep doing that, and I'll do that 2 more times. So then I get, for the next one, I would get 1 equals a times negative 1 squared plus b times negative 1 plus c. So I get 1 equals a squared minus b, that kind of looks like a plus, minus b plus c. And the last one, I would get 1 equals 9 times, a times 4 squared plus b times 4 plus c. Sorry, I'm doing this video at the end of a school day, so my brain's a little tired. Okay, so we have 1 equals 4 squared is 16, so 16a plus 4b plus c. So I have 3 equations with 3 unknowns. This is allowed. I don't know why I wrote a squared here. Sorry. And so I have a 3 variable system now that I can solve. So I will kind of walk us through the initial part of this, but you might want to pull out those, I think it was Unit 3 notes, if you need a quick refresher over that, or rewatch the video, or do whatever you need to, but I'll walk us through this a little bit. So this is where we like to label our equations. So this would be 1, this would be 2, this would be 3, and you can choose to eliminate or substitute. I like to eliminate, especially I would choose elimination here because notice how all of them are going to end with plus c. So it's really easy to just subtract your equations together because c minus c is always going to cancel. So, and when you eliminate, you're going to want to eliminate a combination of both 1 and 2, or 2 and 3, or 1 and 3. But you can't eliminate the same ones twice. So I'll run through that with you. So let's eliminate. So we would have, if I just chose to eliminate 1, maybe I'll use a different color here. So I'll eliminate 1. I'm going to keep that one alone. So we'll rewrite it. I want to subtract. It doesn't matter which one. I'm just going to subtract 2. Okay? I'm going to subtract 2. So I'm going to subtract 1 equals A minus B plus C. So when I subtract, I just need to make sure to keep all that together. So this is going to be 5 minus 1, which is 4. 9 minus A, which is 8. 3 minus negative B. That's really 3 plus B, which is 4B. C minus C is going to cancel. So I'm now down to this. So now I can choose to eliminate 2 and 3 or 1 and 3. It doesn't matter as long as you choose a different combination. So I'm still just going to use 1 again. That's fine. So I'm going to have 5 equals 9A plus 3B plus C. This time let's subtract the third one. So I'm going to subtract 3. You could also subtract 2 and 3. Again, there's no wrong answer there. You just get to pick. Okay. So we have 5 minus 1 again, which is 4, equals 9 minus 16 is negative 7. 3 minus 4 is negative 1, or just negative B. C minus C will cancel. And now I have 2 variables with 2 problems. You can now kind of figure out the rest, right? Run through this problem, eliminate or substitute, and then slowly unravel it. You'll either find A or B. You'll plug that into these. Then you'll now have A or B again, right? You'll have 2 out of the 3, and then you go back into any of these 3 problems to find C, okay? So that at least gets you started on one like that. And I know there's more notes, but you got to check the other video for that one because I have to do that on my Chromebook, or not my Chromebook, on my computer because it requires the app.